Hello, everyone. Good morning, afternoon, and evening. Dear authors and invited guests, I welcome you to Technical Session 11F. My name is Amok Dhamdere, and I will be moderating this session. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is a great pleasure to welcome all of you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026. The 11th edition of this conference is being organized in hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the online event is being held through Zoom from the 9th to the 11th of April in 2026. I hope all of you will be enjoying the knowledgeable and interactive sessions we have planned throughout the day. In this particular session, we will be having 10 presentations where each presenter will be given 10 minutes for their presentation and 2 minutes for question and answers. And on the completion of around 8 to 9 minutes, I will be raising a gentle reminder. And yes, if you have any queries or any problems, you can write it to me in the chat box. Before we begin, I would like to introduce our session chair for today. So our session chair for today is Dr. Kirit Modi. Dr. Kirit J. Modi is the Dean, Professor, and Head of CE and IT at the Sakalchand Patel College of Engineering in Gandhinagar, India, with over 25 years of teaching experience. He has published more than 25 research papers in reputed international conferences and journals. His expertise spans artificial intelligence, cybersecurity, cloud computing, IoT, edge computing, fog computing, and big data analytics. Sir, we welcome you, and I request you to give us your opening remarks, please.
Thank you very much for giving me this opportunity to serve as a session chair, and I'm sure that all the invitee, the authors, so definitely they will share the research insights related to the emerging topics which are relevant to our 11th International Conference on the Information and Communication Technology for Intelligent Systems, and I wish all the best to all of them. And I'm ready to hear, and I hope that all will gain the we can say the objective for which the conference has been organized. So all will get the benefit of the objective of this conference. Yeah, thank you.
Thank you so much, sir. It's great to have you with us today. So our first presentation will be done by Gibi Maria Jose from the lovely professional university in India. And the title of the research paper is A Review on Visual Sarcasm Detection. Ma'am, I request you to start presenting, please.
Okay, sir. Good morning, sir.
Very good morning, ma'am.
Sir, is my video audio clear?
Yes, you are audible and your screen is visible as well. You can start presenting.
Thank you. So my name is Gibi Mariajus. I'm from the School of Computer Science and Engineering, Lovely Professional University, India. Today I'm here to present our paper, A Review on Visual Sarcasm Detection. The work is guided by Dr. Neeraj Mathur, School of Computer Application, Lovely Professional University, Punjab, India. These are our contents: introduction, motivation, methodology, bibliometric analysis, dataset, reason extraction, limitation, and finally conclusion. In today's digital world, especially across platforms like Instagram, Twitter, and Facebook, sarcasm is no longer purely textual. It is embedded in memes, encoded in visual contradiction, amplified through cultural reference, expressed through spatial cue and scene context. Visual sarcasm detection investigates how an AI can detect meaning when the images say one thing but the intent says the other. The problem sits at the intersection of computer vision, natural language understanding, pragmatics, and cognitive incongruity theory. Sarcasm, a sophisticated form of figurative language that acts as noise within the emotional signal of human communication. Sarcasm can disguise negative sentiment behind seemingly positive language or vice versa, creating a fundamental challenge for automated sentiment analysis system when left undetected. Sarcasm leads to misclassification of sentiment polarity, corrupting downstream tasks such as opinion mining, brand monitoring, mental health surveillance, and content moderation. So, why the visual sarcasm detection is important? Social media has emerged as a miniature world of its own, a vast digital ecosystem where millions of individuals interact and express themselves daily. With over 6.6 billion social media users worldwide as of 2025, platforms such as Twitter, Instagram, Reddit, and TikTok have become powerful mirrors of human thought, attitude, and state of mind. Social media holds immense power. It has the capacity to build communities, drive movements, and shape public opinion. But equally, it carries the power to mislead, harm, and destroy when misunderstood or misused. And hence, understanding the hidden intention behind a social media post are extremely important. Second, satirical advertising. Advertising has always been about capturing attention, but in today's overcrowded digital world, traditional straightforward messaging no longer cuts through the noise. Brands are constantly competing for the limited attention span of consumers, and this pressure has pushed the marketer towards more unconventional and emotionally provocative strategies. Companies have built their entire identities around the approach because sarcasm makes people stop, think, and laugh. It creates relatability, especially among millennials and Gen Zs who are naturally skeptical of traditional advertising and respond better to brands that speak their language honestly and humorously. Satirical advertising allows companies to challenge social norms, mock competitors, and position themselves as culturally aware without being preachy. Sarcasm is not merely a linguistic trick, it's a deeply rooted cognitive state of mind. Machine process only the literal surface and completely miss the cognitive gap between what is shown and what is said. This is precisely the problem that visual sarcasm detection exists to solve. Because when a machine cannot tell the difference between what a genuine compliment and a bitter truth, every decision made on the basis of that data is not just wrong, it is fundamentally and dangerously misleading. Automatic sarcasm detection plays a critical important role in measuring the genuine customer satisfaction across both the public and private sector. Because in today's digital communication landscape, the most honest consumer feedback is almost never expressed literally. It is expressed most of time and sarcastically. When a customer is deeply dissatisfied with a product, a service, or an institution, they rarely write a straightforward negative review. Instead, they post a meme, craft a tweet, or create a sarcastic visual that communicates their frustration to humor and irony. In this work, we conducted In this work, we conducted a systematic literature review focusing on visual sarcasm detection research published between 2018 and 2025. To ensure transparency and rigor, we followed the PRISMA 2020 guidelines, which can be illustrated in this figure. For the search process, we designed a structure with 14 keyword combinations. Initially, we identified a total of 7,204 records across all the four databases IEEE, Springer, then Science Direct, and Elsevier. After removing 1,040 duplicate entries and filtering out the irrelevant records, 427 studies remained for screening. During the screening phase, we excluded the studies that did not meet our criteria, resulting in 353. Then reports are being assessed for eligibility. Further exclusions were made based on the factors such as non-empirical work, non-English paper, lack of image modality, and finally, 96 studies were selected for the review. This structured approach ensures that our review is comprehensive, reproducible, and focused specifically on foreign high quality research in visual sarcasm detection. Bibliometric analysis. We performed a bibliometric analysis to understand the publication trend and research evolution in visual sarcasm detection. The results have shown a steady growth in publication, especially after 2020, indicating that increasing research interest in this domain. We also observed that the conference publication dominates in the early years, while the journal publications are increasing as the field matures. Additionally, keyword analysis highlights a shift towards a multimodal learning, attention mechanism, and visual text feature integration. This analysis have helped us to identify the emerging trend and research gap in the field. From this literature, for the ease of study, we divided the datasets into four groups: tweet-based dataset, video and dialogue, meme-specific, and multilingual. Tweet dataset researchers have predominantly have used the Twitter as a source for visual sarcasm dataset, due to its multimodal infrastructures and API accessibility. Next, there were a video and dialogue dataset. The video dataset extended beyond the static images by incorporating the temporal dynamics and conversational context. Then we have the meme-specific dataset, we could see that the researchers have targeted the internet memes with characteristics, images, macros, and overlay text in meme-specific dataset. Then we have the multilingual and cross-cultural dataset, where researchers have found developed multilingual datasets. And our paper have focused listed out the 15 different datasets on this basis. And feature extraction strategies. From our study of literature, we could find that the existing works are focused on the majorly on the four modalities like text, image, audio, and video. These are the here we can see that the earlier approaches were focusing on the TF-DF approaches, but as the time passes out and the it passed out, we can see the researchers have moved to using enhanced BERT, then a combination of VGG16, and so on. Limitations and future scope. Current systems have achieved reasonable performance but provide a limited evidence of genuine cross-model semantic reasoning. Strong text-only baseline, modest gains from the visual input, and non-consistent counterfactual behaviors indicate that models may rely on sophisticated pattern matching rather than structured reasoning about the contradiction between the visual and textual content. As it can be illustrated here, existing visual language architectures rely on implicit distributed representation with cross-model alignment, whereas robust sarcasm detection requires explicit compositional reasoning about semantic contradictions and pragmatic
Excuse
intent.
me, ma'am.
Yes,
Just a reminder, you have 2 more minutes left. Thank you.
okay, we're concluding. So, genuine cross-model model reasoning entails the compositional semantic extraction from both modalities, including the recognition of action, situation, and states in images, as well as the propositional, pragmatic, and contextual meaning in text. Similarly, we need sarcasm from an alternative interpretation, such as factual error, metaphor exaggeration, or informational independence. Although attention mechanisms and joint embeddings have approximate this function, they remain implicit, distributed, and largely uninterpretable, making it unclear whether such architectures compute the structured semantic relationship or merely appropriate the similar input-output behavior. And also in the tech and architectural we can see that the state-of-the-art models for visual sarcasm detection requires a massive computational resource, limiting accessibility, deployment feasibility, environment sustainability. Scaling laws indicate diminishing returns, making brute force parameter growth increasingly inefficient. And in the data section, the existing data sets for visual sarcasm detection remain small, temporally narrow, culturally skewed, and topic limited, constraining generalization and encouraging overfitting to dataset. So, conclusion: visual sarcasm detection reflects the several broader challenges in artificial intelligence, including pragmatic inference, cross-model, semantic integration, world knowledge, and sensitivity to social and cultural context. This review has synthesized existing research and shows that although automated visual sarcasm detection has become feasible, current systems remain limited in their ability. So we are here ends our discussion. We heartfully thank the conference committee for selecting our paper, and we are open to questions.
Thank you so much for your presentation, ma'am. Dr. Modi, do you have any questions for our speaker? Hello, Dr. Modi, can you hear me? Okay, I think he is away from keyboard, but thank you so much for your presentation, ma'am. We can now move on to our next presenter for today. So our next presenter for this session is Mariam Ghazi Ali from the Mahatma Gandhi University in India. And the title of the research paper is Advanced Intelligent Intrusion Detection System for IoT, a review. Ma'am, I request you to kindly start presenting, please. Hello, ma'am, am I audible?
Hello, sir.
Yes, ma'am, you can start presenting, please.
Okay. Welcome to this presentation titled Advanced Intelligent Intrusion Detection System for IoT Review. This paper was prepared by Mariam Ghazi Ali and Bindu Viyar from Mahatma Gandhi University, Kerala, India. At first, let me know introduction about the IoT ecosystem. The Internet of Things has grown into the massive digital ecosystem connected billions of devices in transportation industry, healthcare, and smart cities. While this connection offers significant advantages, they dramatically increase cyber attack, including DDoS, botnet spoofing, malware, zero-day. Also, IoT devices increase this risk due to low processing power, different communication protocol, and lack of common security standard. There are many approaches used. First, the limitation of traditional ideas that Internet of Things. These systems depend on fixed signature database, so they cannot detect new or changing attacks. In addition, real-time multi-class detection is difficult because IoT networks generate large and diverse traffic. Therefore, researchers have started deploying intelligent intrusion detection solution using machine learning and deep learning, which can learn from data and adapt to new threats. So this review examines three main categories of intelligent intrusion detection approaches for IoT. The first one are machine learning methods. It is still important for IoT security because they provide good performance with low computational cost compared to deep learning. Common algorithm that used in this one is random forest, GPOST, gradient posting, supervector machines, k-nearest neighbors, one-class classification, ridge classifier, and logistic regression. These methods are used for tasks such as DDoS detection, ransomware detection, and anomaly detection in healthcare and smart energy IoT environment. So here in this slide, we know some of key studies. Several notable machine learning studies are reviewed, like Odin et al. Proposal layer adapt architectures for detecting both known and unknown attacks using unsupervised methods, and the clustering. Rabia et al. Compare read folks feature selection with radial-based function classification to achieve near 99% accuracy. Khan and Al-Kuthami shows random forest outperforms DNN in healthcare IoT, and Boya confirm random forest superior performance across multi-benchmark data sets. Sakuratel found gradient posting space for DDoS in critical infrastructure, and Lietel reached 94.64% accuracy in ransomware detection. Machine learning approaches are efficient but have some limitation. They often depend on manual feature selection, which makes it hard to detect new type of attacks. Simple models like ridge classifier also have difficulty handling complex attack patterns in modern IoT traffic. However, machine learning models are still suitable for resource-limited environments, and their performance can be improved using better feature selection or hybrid models. So the second approach is deep learning architecture. Also, it's widely used in IoT intrusion detection because they can automatically extract complex features without heavy manual pre-processing. The key architecture includes CNN for spatial pattern detection, LSTM for temporal sequence analysis, and BioLSTM that processes sequence in both directions. Deep neural network for high-dimensional classification, attention mechanism to focus on the most informative feature, and explainable artificial intelligence techniques to make model decision more transparent and interpretable. This slide highlights key deep learning studies reviews like MTM et al. Introduced the explainable IoT framework using spectrogram and CNN with explainable AI. and Moj and Belgiat tackle class imbalance with two-step, one-dimension CNN. Valila et al. Campaign bio LSTM with attention mechanism and optimization algorithm for industrial IoT. Hazel et al. Use a multi-stage deep neural network CNN LSTM pipeline for dose subtype detection. Tasky develop a lightweight one-dimensional CNN for edge devices. Chakraborty et al. Achieve over 99% accuracy using rule-based deep learning for novel attack detection. So the limitation in these models, despite of their high accuracy, deep learning model face real-world deployment challenge. BioLSTM and multi-layer deep learning pipelines demand significant computation and memory, making them unsuitable for low-power IoT devices. Additionally, most studies use standardized benchmark datasets rather than actual IoT network traffic, raising questions about real-world applicability. However, CNN-based architectures are more promising for edge deployment due to their relative computational efficiency. And the third approach, hybrid and ensemble IDS frameworks, also are becoming popular because they combine machine learning, deep learning, feature selection, and optimization methods to improve performance and reduce the limitation of single model, such as overfitting and class imbalance. By combining different approaches, these systems achieve higher accuracy, better robustness, and improve detection of new attacks. Optimization algorithms such as Bayesian optimization, tuner swamps also are often used to fine-tune these methods. Among the most notable hybrid and ensemble studies, Komar et al. Achieved 99.76% accuracy using combination of artificial neural network, deep CNN, BioLSTM, BioGRU, and RNN model on UNSW MP15. Yasser and Diners combine CNN and LSTM with correlation-based feature selection. Tawfiq stacks autocoders with catapult and transform CNN LSTM symbols, achieving 99% accuracy, and Tolcoder et al. Use data balancing and dimensionality reduction with random forest, achieving 99.97% on ton IoT, and Aldag et al. Propose a two-stage symbols for edge IoT, and Vigian and Saunders use tuner swarm optimization to enhance a classifier's performance. But also, here, this type of approach, there are many limitations. While hybrid and ensemble models deliver the best detection performance, they come with significant practical challenge. The combination of multi-machine learning and deep learning model greatly increase computational complexity and system overhead, making them difficult or impossible to deploy on resource-constrained IoT devices. The review identifies created lightweight hybrid frameworks that balance detection accuracy with computational efficiency and the critical open research direction for the field. There are many of performance evaluation and results. The table summarizes detection performance across the review studies. Accuracy is the dominant metric with the majority
Excuse
of...
me, ma'am.
Yes, sir.
Just a reminder, you have 2 more minutes left. Thank you.
Okay. Can I skip this slide?
No, you can
Faster.
actually speak
Okay.
about this slide. I just wanted to remind you that 2 minutes are left.
Okay.
Okay,
The
thank you.
table, thank you. The table summarizes detection performance across the review study. Accuracy is the dominant metric that with majority of model achieving about 99% on their respective benchmark data sets. Notable results include the Talcader achieving 99.97% on Ton IoT, Moj and Belgiat achieving 99.99% on Potnet IoT, and Tawfiq and Chakraborty exceeding 99% accuracy. The discussion highlights the gap between research results and real-world use, although many models achieve over 99% accuracy in experiments. They are largely using in actual IoT systems. Models such as CNN, LSTM, and BioLSTM show strong performance, but most studies focus on specific attack instead of overall IoT security. In addition, explainable AI is still limited in large-scale environments like healthcare and industrial systems. Therefore, future work should focus on lightweight, explainable, and resource-efficient IDS models using age and federated learning to support real-world deployment. So, in conclusion, IoT security needs to move from traditional method to adaptive AI-based solution. Deep learning is effective for detecting complex attack patterns, while classic machine learning is still useful in research-limited environments. Hybrid approach often achieve the highest accuracy but are more complex to implement. So this review also highlighted a common problem many studies rely on artificial or imbalanced data sets. Therefore, future research should focus on using realistic data sets, developing lightweight and explainable AI model, and apply edge learning to enable practical deployment in real-time environment. This is the reference, and thank you.
Thank you so much for your presentation, ma'am.
Thank you, sir.
I now ask our session chair, Dr. Modi, if he has any questions for you. Hello, Dr. Modi, can you hear me? Dr. Modi, hello. Okay, there seems to be some issues, but no problem. Thank you so much for your presentation, ma'am.
Thank you, sir. Thank you so much.
Yes, we can now move on to the next one. So our next presentation will be done by Aditi Jha from the Birla Institute of Technology in India. And the title of the research paper is An Adaptive and QoS-Aware Trust Framework for Secure V2X Communication with Machine Learning-Based Anomaly Detection. Ma'am, I request you to start presenting, please.
Yeah, I'll share my screen.
Sure, ma'am.
Good morning, everyone. I am Aditi Jha, and I'll be presenting our paper on adaptive and QoS trust-aware framework for secure V2X communication using machine learning-based anomaly detection, carried out under the guidance of Dr. Ravi Shankar Pandey. In this presentation, I will briefly discuss the motivation and problem. Then I'll explain the proposed framework and its components, followed by that, the mathematical model and results. So let's begin with some background. V2X communication enables vehicles to exchange safety-critical information like position and speed. This is essential for collision avoidance and intelligent transportation systems. However, due to its open and distributed nature, it is vulnerable to attacks such as false data injection and misbehavior. Additionally, network conditions like latency and packet loss are highly dynamic. However, existing systems have some important limitations. Current systems mainly rely on authentication, but authentication only verifies identity and not behavior. A valid node can still send incorrect information. Also, network conditions keep changing. So, we need a system where trust adapts based on behavior and communication quality. These limitations lead to the following problem. Existing approaches focus on individual factors like trust, machine learning, or QoS separately. This creates three issues. Firstly, trust is treated as static. Secondly, behavioral changes are not captured. And thirdly, communication quality is not fully integrated. So a unified adaptive trust framework is required. Based on this problem, the main contribution of our work are as follows. Firstly, we propose a layered adaptive trust framework that integrates security validation, behavioral analysis, and dynamic computation. Secondly, we define a mathematical trust evaluation mechanism that combines anomaly likelihood, QoS, and temporal weighting. And lastly, we introduce a confidence-aware trust modulation strategy. And then finally, we will validate the framework using a synthetic V2X dataset, demonstrating reliable trust, separation, and anomaly detection under dynamic conditions. To address these challenges, we propose the following framework. This slide shows the layered adaptive trust framework. Each V2X message is processed through multiple stages. Firstly, a certificate validation. The certificate validation ensures authenticity. Then, behavioral features such as position and velocity are extracted. And then, a machine learning model computes anomaly likelihood. At the same time, QoS metrics such as latency and packet loss are evaluated. All these are combined and updated to update the trust dynamically. And finally, the system decides whether to accept, monitor, or isolate the node. Now let's take a look at the key components of this framework. The framework includes 4 main components. The security module handles certificate validation. The behavioral module extracts mobility features. The QoS module evaluates communication reliability. And the ML module detects anomalies. These together contribute to trust computation. To formally define this system, we use the following mathematical model. Each message is represented using identity, timestamp, and payload. We construct a feature vector using velocity deviation, position inconsistency, latency, and packet loss. A machine learning function computes anomaly likelihood between 0 and 1. QoS is also calculated using latency and packet loss to measure communication reliability. And based on this, trust is updated using the following rule. Trust is dynamically updated using 3 factors. Previous trust ensures stability. Anomaly likelihood reduces trust for suspicious behavior. QoS improves trust when communication quality is good. These are combined using weighted parameters. Based on the final trust value, nodes are classified as accept, monitor, or isolate. To compute anomaly likelihood, we use a machine learning model. The model analyzes features such as trajectory deviation, message frequency, latency variation, and packet loss patterns. It outputs an anomaly score which helps detect abnormal behavior. To evaluate the framework, we use the following dataset. The dataset includes diverse vehicular scenarios with varying densities, mobility patterns, and malicious activities. It also incorporates realistic network conditions like latency and packet loss. The overall process is summarized in this algorithm. These are the steps. The system validates the message, extracts features, computes anomaly likelihood, evaluates QoS, updates trust, and then finally makes a decision. Now let's take a look at the results of the proposed approach. On the left, we see a temporal trust evolution. Benign nodes gradually increase their trust over time, while malicious nodes showed rapid trust decay. On the right, we see the final trust distribution. There is a clear separation between benign and malicious nodes with minimal overlap. This shows that trust acts as a behavioral fingerprint, enabling reliable identification of malicious nodes. Now, these results can be summarized as follows. The framework improves trust stability and resilience against attacks such as DOS and man in the middle. It also provides clear separation between nodes behavior and reliable detection. In terms of practical usage, the system can be integrated with DSRC and cellular V2X technologies. It is lightweight and scalable for real-time applications. Now, compared to the existing approaches, we can see that our framework uses dynamic trust, machine learning, and QoS, making it more robust than other static models. Despite these advantages, there are some limitations. The current work is simulation-based and depends on parameter tuning. Future work also includes real-world deployment and advanced learning methods. Now, to conclude, we proposed an adaptive trust framework integrating authentication, behavior, QoS, and machine learning. It improves reliability and enables effective detection of malicious nodes. Now, I would like to thank you all for listening.
Thank you so much for your presentation, ma'am.
Yeah.
Dr. Modi, can you hear me now?
Yeah, hello.
Yes, sir. Do you have any
Yeah.
questions for us, speaker?
So, Aditi,
Yes.
so I would like to know about the applicability of the proposed work.
Yes, sir.
Yeah.
Sir, we till now, sir, we have worked on synthetic data sets because we were
No,
unable
it's
to
okay.
find.
It's okay. I would
Yes.
like to know what are the possible use cases or application scenarios of your work? Have you identified?
Sir, in automatic automobiles, we can use our work of
Okay.
LSTM.
Okay. Okay. Okay.
So
So,
it gives more safety. LSTM method gives more safety than normal safety measures because we are observing the factors over time. So that makes it more suitable and more safer than other methods. That is the things.
right. So at least what you can do, of course, you are working with the synthetic data and
Yes.
you are not deploying the things and all the things, but
Yes,
at the
sir.
same
For
time, at
now, we
least
are working.
you can put a kind of the case study scenario. So
Yes.
it will be helpful to understand how you will apply your work in future when it will be on the deployment aspects. Yeah.
Okay, sir. We will do that for
Okay,
sure.
yeah, fine.
Okay,
Thank you,
thank you
sir.
so much for your presentation, ma'am.
Thank you.
We will now be moving on to the next presentation for this session, which will be done by Sahil Ambokar from the Pimpri Chinchwad College of Engineering in India. And the title of the research paper is An Ethereum Framework for Secure Electronic Voting Systems. Sir, I request you to kindly start presenting, please. Okay, I think he is not present with us at the moment. Any of the co-authors of this paper? Okay, no one. We can move on to the next one then. So our next presenter would be Veenu Singh from the Greater Noida Institute of Technology in India. And the title of the research paper is An Optimized Cryptographic Algorithm for Privacy Preserving Big Data Processing in the Cloud. Ma'am, I request you to start presenting, please.
Good morning, sir.
Very good morning, ma'am.
Sir, wait a few minutes only.
Sure, ma'am, you can take your time. Does it require more time? Because we can take one more presentation in the meanwhile.
Okay, sir. One after presentation, I will give my presentation.
Okay, sure. Absolutely. No problem, ma'am.
Thank you. Thank you so much, sir.
Yeah. So we will be moving on to the next one momentarily, which will be done by Sanjit Ganesha P. from the Amrit Vishwas Vidyapeetham in India. And the title is Bias Aware Legal Case Classification and Judgment Interpretation. Sir, I request you to start presenting, please.
Hello, sir. Can you hear me?
Yes, you are audible to me.
Sure. 1 second. Give me. I shall share my screen.
Sure, sir.
Okay. Is my entire screen visible now?
Yes, your screen is visible to me.
Okay. Good morning, everyone. I am here to present bias-aware case classification and judgment interpretation, a step towards making AI not just powerful, but fair, transparent, and accountable. So, starting with the challenges that we face usually when it comes to bias-aware judgment prediction, uh, and that too using AI. AI is rapidly transforming the legal domain from case analysis to judgment prediction. It promises speed and efficiency, but there are other serious concerns, such as most legal judgment prediction systems are trained on historical data, which often contains like implicit societal biases such as gender or occupation or caste or some other socioeconomic status. So instead of removing the bias, AI could actually amplify it. So that's what we are trying to implement in our work. And in the domain like law, even a small bias can lead to unfair and unethical outcomes. So the research gaps that we have found are, first, most models prioritize accuracy over fairness, but in legal systems, fairness is more critical. So consider a place where the system is giving a 99.99% accuracy, but the outcomes are not proper, or the outcomes are very biased. So the problem lies over there. And the second research gap that we have came across is a very few approaches treat bias awareness as a core design objective. It's often an afterthought. The third is that there is a limited work in the Indian legal context, especially in the structured bias mitigation. So this clearly shows that while AI is advancing technically, it is still lagging in ethical outcomes. So the solution that we have proposed is to address these issues. The idea is simple yet powerful. So we have used one encoder which focuses on the bias-free legal reasoning, while the other captures the full contextual information. So this is a dual encoder model. So initially, the legal word will be processing. Okay, starting with bias-aware processing. Initially, the data is masked, and then it is passed to the dual encoder, where the legal BERT is processed on the masked data while the BERT handles the unmasked context, and the gated fusion will occur using the MLP technique. And the methodology overview here states that first, initially, we have started with the data collection. We have only focused on a very few IPC sections, considering there are so many IPC sections in Indian legal system. So the main IPC section that we have focused are lies between the range 299 to 316. So secondly, we will be applying the bias aware processing where the sensitive attributes are masked. And then third, we will be performing the representation learning using legal BERT and BERT, capturing the complementary insights. So the representation learning, which means that we are using a dual encoder to achieve this representation learning. And finally, we'll be using the MLP technique to fuse these outcomes, like whatever the output is given by the legal BERT and the BERT and the BERT-based model. We'll be fusing it with an MLP classifier, and we will be doing the probabilistic prediction, and then we will be pushing it to a decoder so that we can get out the best results. So this is our dual encoder decoder architecture. So this diagram illustrates that we'll be using one masked version. So this is the bias annotation tagging pipeline where the named entity recognition will be happening, and then a zero shot bias classification and filtering bias named entity will be happening. Followed by it, we'll be generating the bias tags, and then we'll be masking them. While the unmasked data has been fed to the BERT based model for bias aware learning, while the masked data is fed to the legal BERT for the um, learning of legal words, so that we could avoid any biases that would occur in the future while generating the results. So these two are being fused using a fusion decoder where we'll be using the MLP technique. And finally, the final judgment that has been predicted will be compared with the actual judgment, and we will be doing a comparative analysis and a Z-score analysis. So the main uh, the source of our data, where we took our data from, is Kanun dataset, where it's a website where the High Court judgments and other case-related documents could be found. And the main key innovation is that using named entity recognition and zero-shot classification, we could identify sensitive information like gender, caste, religion, and age. We replace them with neutral tokens, and following this, we could be preventing the model from associating outcomes with demographic traits. As a result, the model focuses only on casual legal factors, improving fairness and consistency. And finally, going with the performance comparison. This table shows the performance comparison of the models. While the BERT model and the legal BERT model showed a decent comparison, decent accuracy and precision, and also recall and FN score. These are the four performance analysis metrics that we have taken. Because usually opting to one more modern comparison techniques um, will cause might result in wrong, like might result in not giving the actual results. So we have adopted to a more traditional methods of finding comparing the results of the given models. And followed by it, this graph represents the metric visualization of the metric visualization of the different different encoders that we have taken. So we could see that the loss is being decreased while the accuracy is being increased. And finally, the interpretability and transparency. One major issue with AI system is the lack of transparency. We address this by making our model interpretable. We provide highlighted sensitive spans, attention-based reasoning, auditable decision processing. This allows legal professional to understand why a prediction was made. And importantly, our system is designed as a decision support tool, not a replacement for the judge. And finally, the impact. Our system has several real-world benefits. It reduces the time required for legal analysis because in times we have to go through multiple documents to understand what the case is actually about, which means that you have to apply for the case, you have to apply for about the cases to the courts, and then the judge will be going through the entire documentation each and every time, which is hugely time consuming. So this could be avoided by this approach, and followed by it scales across multiple legal domains. It builds trust through transparency. And the future directions. Looking ahead, we aim to extend this to multilingual legal systems, improve explainability using advanced techniques, expand the border domains like civil and constitutional laws. Currently, we have just focused on a limited set of IPC sections. So the future direction could extend on multiple IPC sections, and you can also include multiple domains of laws such as constitutional law, international law, and so on. So thank you, everyone.
Thank you for your presentation. I now ask our session chair, Dr. Modi, if he has any questions for you.
Hello.
Yes, sir.
Yeah, Sanjit. So, have you interacted or taken any kind of the feedback, opinion from the people who are working
Of the
in the
legal
legal
domain.
system?
Yes, sir. We have actually the Amrita actually has a school of legal or the law, school of law. So basically, the staffs from those departments actually helped us to understand what actually these IPC sections are about and how we can achieve this through LLMs and NLP models. So we have actually consulted them.
So actually, what I know is that I think there is one popular platform developed by the IBM Watson, right?
Yes, sir.
So I think it is, I think commonly used for this kind of the, we can say the applications requirements, right? But now there is a need to think about the one part. It is about when you are saying about the bias system, right? So there is a need to think about the how to make the AI trusted, right? That is one part. And second thing is sometimes you have to work with more than one systems in a way that you can get a kind of the fair, we can say the outcome, right? Are you getting this? For
True, sir.
example,
True, sir.
sometimes you should
Yes,
be
sir.
in a position that, for example, if I want to buy a product, then there should be more than one platforms where I can even at least get idea about that product, the review, specification, price, everything. So similarly, there should be a kind of the mechanism in this kind of the area also, right?
True, sir.
Yeah. Okay. Thank you.
Thank you, sir.
Okay, thank you so much for your presentation, sir. We will now be moving on to the next one. Before that, I would like to ask Mrs. Veenu Singh, have you managed to solve the problem that you were having?
Yes, sir.
Okay,
Now I'm
you
ready
can
to
start
present my
presenting now.
presentation.
Sure, you can start presenting.
Okay, I will share my screen. I'm ready.
Yes, we can now see your screen. You can start presenting, please.
Yes, sir. Good morning, all. I'm Vinu Singh here. I will represent my work regarding my topic is an optimized cryptography algorithm for privacy preserving big data processing in the cloud. What is cryptography? Cryptography is the science of securing information by transforming readable data into an unreadable format using mathematical algorithms and keys. The abstract is with the development of cloud computing and big data technology, data handling, particularly in handling big data, while also maintaining the dangers of privacy and security. Violation in delegating the processing of sensitive data to cloud computing has increased day by day. It increased. The conventional encryption method that demands the decryption of data for processing, which could result in the leakage of sensitive data and performance inefficiencies, are no longer valid. My paper introduced the optimized privacy preserving cryptography processing algorithm, OPCPA, which reduce computational complexity through the use of lightweight encryption, adaptive data partitioning, hierarchical key management, and parallel processing of encrypted data. The proposed algorithm is compared to conventional method using the KDT curve 1999 dataset and outperforms them in the terms of processing speed, throughput, and resource utilization. Introduction. The increasing rate of digital technology and intelligent applications has led to a massive amount of data being created in various sectors, known as big data. This has led to a paradigm shift in the management and processing of data in the organizations. The cloud computing has become the most widely adopted technology to deal with big data due to its scalability and cost effectiveness. But the transfer of sensitive data to the cloud platforms has raised serious concerns regarding data privacy and security, as the data owners no longer have control over their data. The paper introduced an optimized cryptography algorithm designed to enhance privacy, preserving big data processing in a cloud environment. It addresses the computational inefficiency of current cryptography method while ensuring robust security against threats. The proposed framework supports efficient operations on encrypted big data through lightweight cryptography operations and parallel processing, as we have discussed earlier, facilitating secure data analysis with reduced latency and resources use. The main contribution of this work include identify privacy and efficiency challenges in the processing encrypted big data in the cloud, developing a cryptographic algorithm tailored for a cloud analytics, enhancing efficiency and reducing computational complexity, conducting a thorough security analysis against common cloud attack models, and experimentally verifying the performance advantage of the proposed approach compared to existing encryption method. Related work. The key area of interest is in cryptography method that can securely protect confidential data while facilitating secure computational on the cloud infrastructure. Homomorphic encryption is a significant breakthrough in the cloud computation privacy preserving paradigm that allow computationals on ciphertext without revealing the plain text. The author represent a fully homomorphic encryption FHE method which focus on the functionality of encrypting data throughout its life cycle while supporting computational operations on the public cloud platforms. Although HE supports strong security functionality for big storage and computation, recent research has shown that HE incurs computational overhead, processing delay, and significant ciphertext expansion, making HE inefficient for big data analysis. So, therefore, there is an increasing need to optimize cryptography solution to improve efficiency without sacrificing security. So, we use the combination of attribute-based encryption, ABE, and fully homomorphic encryption, FHE, which improves secure communication system by enabling computationals on encrypted data and secure data transfer. The author in conducted experiment using ciphertext policy attribute-based encryption and improved system throughput and latency management for secure data transfer in distributed smart environments. Research on privacy-preserving big data platforms aims to combine distributed processing paradigms like MapReduce, which homomorphic encryption for secure big data processing on platforms like HDFS. This includes overcoming the requirement for reduced cryptographic complexity and improving privacy by leveraging the synergy between cryptography and differential privacy. The literature highlights the necessity of cryptography method to protect big data privacy in cloud processing, focusing on homomorphic and attribute-based encryption. EBE hybrid privacy model enhance resistance to interference attacks. However, challenges such as scalability, encryption latency, and resource demands indicate a research map gap for optimized cryptography algorithm in big data. System model and problem formulation. While offering scalability and cost-effective solutions, cloud computing threatens big data's confidentiality, integrity, and privacy. To address these issues, a comprehensive system model is necessary to resolve these problems, outlining secure stakeholder interaction and specify security goals and optimization needs. This section covers the architectural framework, threats analysis, design requirements, and a formal problem statement for a cryptography algorithm to ensure privacy in cloud-based big data processing. Problem statement. In big data cloud infrastructure, although there has been process in cryptography security, traditional privacy preserving methods are challenging. Homomorphic encryption provides high confidential, but it's computationally intensive. Attribute-based encryption provides flexible access control, but it's complex in key management. The objective is to enable the cloud to carry out analytical computations on a dataset where D is represent the dataset. My dataset is D is equal to D1, D2 up to Dn without disclosing the original data. The basic challenge can thus be stated as Fd is equal to D in bracket K compute encryption K comma D where ENC in bracket KD is the encryption process using the key K. Compute is the cloud computation. D of K is decryption process using the key K. The optimization problem is to develop a cryptographic system with the lowest computational complexity while it still satisfies the security minimum under bracket TE encryption plus T processing plus D decryption, where T ENC represent encryption time, T processing time, T decryption time. Process optimized cryptography algorithm. The process optimized cryptography algorithm you utilize.
Excuse me, ma'am.
Yes, sir.
Just a reminder, you have 2 more minutes left. Thank you.
Okay, sir. I will finish within 2 minutes. Basically, we are using some cryptography algorithm to encrypt my data. So this is some algorithm. The proposed optimized cryptography algorithm utilize high encryption, computational optimization, and parallel processing techniques to enhance the efficiency of privacy preserving big data analytics in cloud computing. This is the format of key generation mechanism which we use in our algorithm. The proposed algorithm employs a hybrid lightweight key generation mechanism and this is the optimized encryption phase. The encryption mechanism combines lightweight symmetric transformation with secure masking operations. These are some operations which are performed on it. Secure processing over encrypted data. A major contribution of OPCPA lies in enabling limited analytical operations directly on encrypted data. Cloud server execute computation function using transformation preserving properties. This is the main algorithm pseudocode where input dataset D, output secure process result R. First, we generate master key EM partition dataset into blocks BI. For each block BI, generate session key KI permutation PI and compute mask MI. Encrypt CI BI XOR PI plus MI. Upload encrypted block CI to cloud. Cloud perform computations on this block. Return encrypted result. Authorize user decrypt BI is equal to this one. merge result to obtain. Experimental setup. The experimental setup focusing on validating the proposed algorithm within a real big data processing content utilizing the KDD Cup 1999 dataset from the UCI machine learning repository for consistent experimental validation. The hardware and software configuration for the experimental shown in the table. The conclusion of this is the article propose an optimized privacy preserving cryptography processing algorithm for secure big data processing in cloud computing. It overcomes the security and efficiency issues raised by the conventional cryptography approach, enabling analytical processing on encrypted data without decryption. The proposed algorithm combines lightweight encryption, adaptive data partitioning, and hierarchical key management, achieving substantial improvements in encryption speed, processing efficiency, and scalability over the conventional approach, such as AES and RSA. The experimental results confirm the effectiveness of the proposed algorithm in practical applications, encouraging improved data security without sacrifice efficiencies. Future work will be focused on quantum resistant and Internet Things based OPCA models. Thank you, sir.
Thank you so much for your presentation, ma'am. Dr. Modi, do you have any questions for our speaker?
No, it's okay, fine.
Okay, thank you so much for your presentation, ma'am.
Thank you, sir.
We can now move on to the next one we have. So the next presentation will be done by Kashish Goel from the Thapar Institute of Engineering and Technology in India. And the title of the research paper is Casual Categorization of Adulterant-Specific Sensor Responses in Multi-Sensor Milk Detection. Ma'am, I request you to kindly start presenting, please.
Yes, sir. Is my screen visible?
Yes, your screen is visible and you are audible as well.
Good morning, everyone. I'm Dr. Kashish Goel, and I'm from Thapar Institute of Engineering and Technology. My paper topic is causal characterization of adulterant-specific sensors in multi-sensor milk detection. So these are topics I'll be covering. So basically, what we are doing in this case is that whenever milk is a major reliable major food for all of us, and in this case, it is a major safety issue. Why? Because everyone is concerned about, even for a newborn infant or a big person, everyone drinks milk. So in that case, milk adulteration is a very common thing. But generally, what we are doing is machine learning models we are doing, but no one is concerned about that what happens when actually the adulterant is added to the milk. So in this case, in this work, we have done some intervention based analysis, that is the causal analysis, not relying on the correlation but relying on the intervention based causal analysis. So we have identified the major parameters that are adulterating milk. So in that case, we are doing this. Next we have is the literature survey. These are some of the works that we have. Most of the people have applied deep learning and machine learning models to achieve this. And then what they have taken out some different sensors, and then they have applied explainability. But these are all correlation based. But what we have done in this case is that we have taken causality analysis. That what happens when when one adulterant is added to the milk, and what happens to the sensors in that case. These are the research gaps that existing ML and AI XAI approaches provide prediction and feature importance, but they do not give the proper understanding that how are these happening, what is the actual relationship between the current cause and effect. So in that case, these cases, particularly in milk adulteration, these parts remain unexplored. Next is, as we all know, that what is correlation? Correlation moves, variables move together. But what causation does is that intervention causes change. When one adulterant is added to the milk, it gives the change in another sample, another milk. So that is what we are studying, that how these different adulterants are working. These are my objectives: to quantify the causal effect of the adulterants on sensor responses, understand how and why sensors respond under controlled intervention, distinguish direct physiochemical effects from the compositional changes, sorry, introduce the causal system. Next we have applied this structural causal model SCM to identify multi-sensor milk adulteration detection system and estimate adulterant specific causal effects across sensors. We have provided the mechanistic interpretation of sensor behavior, and in this we have not used ML, we have extended the existing work, and in that case, unlike explainability, our approach identifies the true causal effects rather than model-based associations. Then, based on the validated system, our dataset includes around 1500 samples and 6 classes, and adulteration is performed in under controlled laboratory, means we have manually adulterated the samples, and then we have captured the responses. And in this, we have taken some primary sensors and some additional samples. And the primary sensors are the electronic conductivity, pH, and the gas sensors. And then the additional ones are the temperature, compositional parameters, fat, protein, lactose, SNF, and specific gravity. Then in this work, we have developed a separate causal layer for these primary sensors. This is the basic outline of the work, that how we are performing. Next we have is the causal modeling approach. What we have focused is on that what EC, like major and most effective ones were the EC and the pH sensors. In this case, ionic changes were happening, and in pH, acid base effect were there. So this is my methodology, that there is, whenever the adulterant is added, what happens to these sensors. When we have used 5 different types of adulterants: urea, starch, maltodextrin, sodium bicarbonate, and formaldehyde. And for each of these sensors, we have calculated the amount of the causality, that how it is affecting the sensor. Linear model is used to interpret the average treatment. Then model is evaluated based upon that, and these are my key findings: that major for EC sensor, sodium bicarbonate was giving the major effect. So it was the ionic change because of this, and the causality was around 13.19, and R square was around 0.85. And for other adulterants it was negligible, and for pH also it was giving reverse effect. For sodium bicarbonate it was increasing, and for formaldehyde it was decreasing, and for gas it was not much reliable. Then these are the results in these are the causal effects, standard errors, and how 95% confidence, and the p values for different sensors we have got. Next we have is, as we have already discussed, that EC was giving the major case in case of sodium bicarbonate, and for pH it was for sodium bicarbonate and for formaldehyde. Then the standardized effects, because every sensor works on a different scale. So we have standardized the values and then calculated the result. In that case also, again, the sodium bicarbonate for EC was giving a dominant effect, and for moderate effects for pH, and in case of formaldehyde. But for gas, it was not that strong. Then we have is for standardized results for these are the table values for the same method that I have done. This is the graph representation. Further, I have explored the other parameters also that we have included, that is the SNF, lactose, and specific gravity. And for these cases, for these parameters also, we have calculated the causal effects and calculated for protein as well as for fat. These are the different values that we have calculated for different sensors and for different parameters. Further, to check the robustness of the model, we have added some noise for around 5% and 10%. Still, the results were same. The main focus of the work was that we have to analyze different adulterants, that how these adulterants are actually affecting the sensors. Causality scenario, intervention-based analysis has been done. These are the results under different robustness noise parameters. And then we have the major insights are that again I have discussed that the EC is giving a strong ionic response and pH is giving the acid base mechanism, as we all know about its pH sensor. Then the gas, in case of gas, it was not stable causal signal. And again for other variables also it was a primary work. pH captures the bidirectional effects, and for EC, it was giving a strong response for sodium bicarbonate. For gas, it was not giving a lack causal behavior. For compositional variables, downstream propagation was there.
Excuse me, ma'am.
Yes, sir.
Just a reminder, you have 2 more minutes left. Thank you.
Okay, sir. And then for downstream propagation means that these are the primary sensors, EC, pH, and gas, and how these are sensors affecting the other parameters, that is the SNF lactose values that we have studied over here. Then we have is conclusion, and in this again the conclusion, EC, pH are the major sensors that is affected by the different adulterants. And in future, we are going to extend it to other nonlinear models and other real world and mixed adulteration scenarios. Thank you. That's it.
Okay, thank you so much for your presentation, ma'am. Dr. Modi, any questions for our speaker?
So, ma'am, I would like to know where we can actually apply this solution.
Sir, this is a very normal use case. Like I have already discussed that, like in case of milk adulteration, everyone is concerned about the food safety these days. So in this case, like we are generally we what we do is we are taking machine learning models or deep, not only milk, we can apply to other use cases also, that what the actual effect is giving to these. Whenever adulterant is added, is it affecting the sensors? How is it affecting? Is it giving a positive or negative effect? How much effect it is giving? So all these things that we have studied in this case.
So
Just
I
to
think,
what happens in explainability? Explainability justifies the model, that what we have done, like sharp we apply or and lime we apply. In that cases, that it discusses about the model results, that how model has performed. But in this case, we have done intervention, that what happens when one effect causing the other effect. So that cases, so not only to milk scenario, we can apply to other scenarios also wherever this can be used.
yeah, but now if we consider the milk product, right?
Yes, sir.
Yeah, even so now we have a very sophisticated, we can say sensor based, IoT based, the equipments
Yes, sir.
are already are in use, and because of that now we are able to measure, we can say the key parameters
Yes,
or
sir.
quality, right? So this is now happening, but at the same time now, whatever you are telling, so you have to now provide that the reason why we require to now go for this kind of the
This
automation.
is just a further analysis. It is not affecting the existing results. Existing results, whatever is being done, IoT based sensors are used, everything is fine. This is just a further analysis on the existing work itself, that how these the work that we are doing, we can analyze. It is giving a different perspective to the existing work. That's it.
No, but what I feel is that there is a need to even sometimes what happen there kind of the certain things which are when added to the even milk, right? So even it will be difficult to identify and the things, right? So there is a need to work on this area, and it is equally important to enhance, right, the existing the hardware solutions.
Yes, sir.
Yeah,
Yes, sir.
yeah, there is a need. So what I feel is that there is a need to work in that area. What are the actually challenges they are actually these people they are facing who are working with this milk product. Not only I can say the only the milk, but milk
Sir,
products
yes, sir. Sir, adulteration
like
is
for
very
example
common.
paneer and all other things, right? Even we can see there is a very serious concern regarding the paneer, right? Yeah.
Yes, sir. Yes, sir.
Yeah. So yeah, there is a requirement and there is a good scope in this topic in this area. Yeah.
Yes, sir.
Yeah. Thank you.
Okay, thank
Thank
you
you.
so much for
Thank
your
you, everyone.
presentation, ma'am.
Thank you.
We can now move on to the next presentation for this session, which will be done by Nguyen Trong Han. I apologize for any mispronunciations, from the Air Defense Air Force Technical Institute in Vietnam. And the title of the research paper is Classification Performance of Linear Frequency Modulated Signals in an Autocorrelation Processing Device. Sir, I request you to kindly unmute yourself and start presenting, please.
Yes. Do you hear me clearly? Yes.
Yes, I can hear you, sir.
Yes. Do you see full screen?
Yes, we can see your screen, sir. You can start presenting now.
Yeah. Hello, everybody. My name is Nhan. I'm a researcher of Technical Institute from Hanoi, Vietnam. Today, I want to tell you about the topic classification performance of linear frequency modulation signal in an autocorrelation processing device. Since in modern emitting radioelectronic means, not only simple radio pulses are used, but also complex signals, the linear frequency modulation and phase shifting signals. In the means of radio monitoring, it is required to apply special algorithms for their reception and processing. When conducting radio monitoring in complex electronic situation, an important question is determining the type of modulation. Unlike radio monitoring means of location, navigation, and communication, for the means of radio monitoring, the parameters of the signal are a priori unknown, and therefore their optimal processing is possible using an autocorrelation processing device. However, influence the ratio between the input bandpass filter bandwidth and the spectral width linear frequency modulation signals on their classification performance remains insufficiently investigated. This limitation prevents complete ratification of the parameters of the autocorrelation processing device. A purpose of the work shown on the slide number 2. Figure 1 show structure scheme of autocorrelation processing device to determine the modulation type in the autocorrelation device. The following steps are performed. First, multiply the signal with its delayed copy, and then extract the allow companion, allow frequency companion, and companion at the differential frequency in the resulting spectrum, and double the frequency of the received signal. Multiply the signal at the double frequency with its delayed copy. Extract the low frequency companion and companion at the differential frequency in the resulting spectrum for the double frequency. And then compare amplitudes of the four spectrum companion obtained with the given threshold values, and decide on the type of the detected signal. For looking clearly processing detected signal in the autocorrelation device. On the slide show as differential frequency in the resulting spectrum signal. Figure 2 for simple pulse. And simple signal is characterized by a low frequency companion at the differential frequency, which is close to zero frequency. The same is true for the original simple signal at double frequency. Figure 3 for linear frequency modulation signal. The original linear frequency modulation signal is characterized by the presence of a companion at the differential frequency. Due to change in the instantaneous frequency of the signal during the delay, and the low frequency companion of linear frequency modulation signal are close to zero. And the same is true for the original signal at a double frequency. Figure 4 for phase shifting signal. As for the binary phase shifting signal, his companion at the differential frequency after doubling frequency is close to zero. Thus, by checking the presence or absence of companions, it is possible to determine the modulation type of the received signal. Based on the decision made in threshold device, the modulation type of the received signal is determined shown at the table 1. Given that in practice, linear frequency modulation signals have the largest band among the three signals. And for example, synthetic aperture radar, SAR, linear frequency modulation signals have the widest spectrum. And to assess the influence of the ratio between the input bandpass filters bandwidth and the spectrum with linear frequency modulation signals on the dependence of the probability of correct classification on the signal-to-noise ratio, a computer simulation was performed in the MATLAB environment. Initial data of signals show on the slide 8. Results modulation show on the slide. The characteristics for the false alarm probability 10 to the minus 3, figure 6. For the false alarm probability 10 to the minus 4. And figure 7, for the false alarm probability 10 to the minus 5. From this result, we can estimate the signal-to-noise ratio when the probability of correct detection equal 0.9. A result of estimation shown on the slide. And from from the results of simulation, we can give the important conclusion that bandpass filter extract the different frequency component of the complex signals, and efficient detection and classification of linear frequency modulation signal are achieved when the ratio of the bandpass filter bandwidth to the linear frequency modulation signal spectral width does not exceed 100. Conclusion of the workshop on the slide. Thank you for your attention.
Thank you so much for your presentation, sir. Dr. Modi, any questions for our speaker? Hello, Dr. Modi, can you hear me? Okay, I think he is AFK, but no worries. Thank you so much, sir, for your presentation.
Thank you.
We can now move on to the next presentation for today. So our next presentation will be done by Maria Veronica Alderete. I am sorry for any mispronunciations, from the IIESS CONICET in Argentina. And the title of the research paper is Territorial Conditioning of Intention to Use AI in Latin America, Mind the Digital Divide. Ma'am, I request you to start presenting, please.
Can you hear me?
Yes, ma'am, I can hear you, and your screen is visible as well.
Okay. Well, good night here in Argentina. I'm Maria Verónica Alderete. I work at CONICET, which is the National Institute of Science and Technology in the country, and in the Department of Economics, Universidad Nacional del Sur, Argentina. Well, which is the idea of this paper? First of all, we can witness here in the LATAM countries a dual framework. On the one side, there are still many people in Latin America without internet access. On the other side, there is a huge population with an increased adoption of AI and digitalization. So this gap, this distance between those who have access to technology and those who do not is still present. And the idea of the paper is to examine the relationship between intention to use AI and the digital divide, with a relationship with the regional heterogeneity in the countries, which is the research gap. There are many studies about AI intention to use and the digital divide, but less studies that use regional or local data. What about the Latin American countries? The AI adoption is well above the average global level. It's more or less 80%. For instance, Brazil, 76% of AI engagement. But the adoption has nothing to do with AI capacity, with investment, with real appropriation and value creation. So we have to invest more in data, in digital skills. So the idea of this paper is to present this relevant concept together to explain better this digital gap in the literature. The theoretical framework is based mainly on the technology acceptance model, which is widely known in the literature. The idea is that the dependent variable is going to be intention to use AI. We are not going to talk about perceived usefulness or ease of use, because the idea is not based on a survey conducted to individuals, but we use data from regional information from the Google Trend, as we are going to explain later. So the TAM model is going to be the theoretical framework. The digital divide, we all know that there is a first, second, and third digital divide in terms of access, use, and ICT appropriation of the technology. And of course, we have to take into account the artificial intelligence gaps in terms of infrastructure, data, servers, advanced computing, and digital literacy. So the methodology to examine the relationship between these concepts will be the covariance-based structural equation model, because the idea is to test the theory of TAM model, which is an extended theory of TAM, because we are not using just intention to use, but also socioeconomic indicators to explain adoption. The sample is built or is compound of 208 regions from 10 countries, Latin American countries. These regions comes from the search intensity of the Google Trend search by looking at the terms ChatGPT and artificial intelligence. The idea we have different regions for the period September 24 to September 25. And the model to be estimated is there in the figure. You can see that the main dependent variable is intention to use AI. The second endogenous variable is internet access. So we are talking about how to explain internet use at the regional level by taking into account the digital divide, which is the first digital divide, the infrastructure by the presence of data centers in the regions, the rurality, which is the proportion of rural population in the region, and at the same time, other socioeconomic variables, for instance, education, which is the mean years of schooling, the regional participation in the gross domestic product, and the presence of the labor market based on the platforms like Uber. This is a nice contribution because we are talking about the relationship between the gig economy, that is the informal economy, which is very expanded here in the Latin American countries, and its relationship with the intention to use AI, that we are going to see there is a very positive feedback here. So the idea is to test all of these hypotheses, and you can see that data centers and rurality are going to exert, if we have a significant effect, a direct and also an indirect effect on the intention to use AI. Well, the key variables are described here in the table. As you can see, internet at home, which is the percentage of households with internet access. All this information, which is at the regional level, comes from the national censuses. For instance, in Argentina, we have INDEC. In Brazil, we have IBGE. Chile, all the institute publish information about the proportion of households with internet access. We have also information about the average years of schooling, the proportion of population in rural settings. Data centers, here is a binary variable which exerts, digamos, the presence of data center in the region. This information comes from the data center map database. Income and Uber index. See, this is the most original contribution because we try to capture the idea of the informal labor market and its relationship with the artificial intelligence platforms. And with Uber, for example, the platform publish information about which are the cities where the application exists. We don't have exact information about the number of drivers of Uber per region, sorry, but we have information about which are the cities from each country where the Uber platform is present. On the one side, so we have the list of cities. We also have the number of downloads of the Uber app per country, and we have information
Excuse
about
me, ma'am.
the see.
Just a reminder, you have 2 more minutes left. Thank you.
Okay. And also we have information about the number of the size of the population of each country, of each city, sorry. So with this information, we can build an idea of which is the ordinal ranking of the cities and of the region to build a qualitative indicator of Uber presence in each of the regions. Going from 1, which is very low, without adoption of Uber, to 5, which is very high. After doing this estimation, we obtain a very good goodness of fit of the same model, just sharing here the root mean square error approximation, which is very good, below at the 5% significance level, and all the other indicators of goodness of fit, which are shared in the paper. In this slide, you can see which are the statistic significant variables in the model. So internet home access, which is the endogenous variable, the digital divide, explains positively and significantly the intention to use AI. There we can confirm the relationship between the digital divide and intention to use AI. We can also see that the Uber index, the gig economy, exerts a positive and significant effect at the 5% level. The digital skills, a positive and significant effect at the 1% level, and rurality would exert a significant effect too. So on the other side, the connectivity determinants of internet access at home are data centers with a positive effect and rurality with a negative effect. So if we go to the model that we estimate, we can see that all the rows are significant except for income and data centers in its direct effect, and all the others are significant. So what about the discussion? The idea is that if the internet access at home exerts a positive effect on intention to use AI, it's obvious that the adoption of technology is going to make or reinforce the inequalities that are present here in the Latin American countries. Artificial intelligence gaps replicate earlier internet device. Adoption is not just attitudinal, it is structurally embedded because it related with digital skills, with the informal economy, and of course with the digital infrastructure related to data centers and internet access at home. The most important contribution has to do with the gig economy as a vector where we can interpret this result as Uber workers act as early adopters due to the relationship between the algorithm and the intention to use AI. So to conclude the presentation, artificial intelligence adoption in Latin America is structurally conditioned by infrastructure, geography, human capital, and the new labor market dynamics, which is referring to the Uber platform use. So without coordinated digital policies, AI diffusion risk reinforcing existing regional disparity rather than mitigating them. Well, the idea of the paper was to bring some new evidence based on regional level that is based on the Google Trend search, and to continue with future research in this line. I'm sorry because it's very late here in Argentina, so I try to do my best
It's
to
absolutely fine,
be
ma'am.
clear.
Yes, thank you so much for your presentation. Dr. Modi, do you have
Okay.
any questions for our speaker? Okay, I think he is still unavailable, but no worries. Thank you so much, ma'am, for your presentation. We can
Okay.
move on. Yes. So our next presentation will be done by Donald Flywell Malanga from the University of Cape Town in South Africa. And the title of the research paper is The Impact of Post-Adoption Expectations on Continuance Intentions of Community Health Workers to Use mHealth in Malawi. Sir, I request you to kindly start presenting, please. Okay, I think he isn't present with us. Any of the co-authors? Okay, they are absent as well. No worries. We have one more presentation that we need to get done. So the next presentation will be done by Soumyadeep Basak. He would be presenting on behalf of Shubham Sahu. And the title of the research paper is Session Level Imposter Detection Using Mouse-Based Behavioral Biometrics. Sir, if you are present, please start presenting.
Sir, is my screen visible and is my audio audible?
Yes, both of them are true. So you can start presenting, please.
Okay, thank you, sir. So, good morning, everyone. I am Shomadi Bosak and I am presenting my work, Session Level Imposter Detection Using Mouse-Based Behavioral Biometrics. Now, the main problem is that most systems today rely on password-based authentication, which only detects and verifies the user behavior at login. But see, once the login is successful, there is no further verification. So if somehow credentials are stolen, an attacker can still operate undetected. This leads to the problem of session hijacking. So this creates a major security vulnerability, I think, in various sensitive applications which don't use multi-factor authentication. So basically, what we wanted to create was more of a continuous authentication system for each sessions. And instead of relying on network data, which are already prevalent, we went for using the behavioral data of users. This doesn't require any additional hardware as well and can take place directly in server only. Before going to my actual objective, I'm explaining a bit more in literature review and research gap. So we analyzed various existing approaches. So for this behavioral authentication detection, earlier work used mostly statistical models or deep learning models such as ADIMA, CNNs, LSTMs. There have been some hybrid approaches combining keystroke and mouse data, but most of the work I reviewed suffer from key limitations. The most primary one is the closed set assumption. For all of these methods, closed set assumption means that they are trained on a particular set of users, and for the specific users only, they can predict beforehand. So let's say it was trained on 5 users and a 6 user comes into view, it has to be retrained again and again. This is the second issue with the closed set, that the retraining is always needed. Other than that, there are some privacy concerns as well, as we directly cannot store the raw behavioral data obtained from user, since if it's still leaked, the user can still replicate it somehow. Coming to our main objective, it is basically enable authentication with the model and without any need for user retraining. And we wanted to make it one shot, since if the user has at least one verified session, we can work with that. Further, to ensure and preserve user privacy, we are storing the data as non-reversible embeddings instead of raw data. That way, it is not possible to track to the original data. Now coming to the data set we used, this had originally it had the basic features like timestamp, current X and Y coordinates, and the event that has taken place. So mostly I use two data sets primarily, the SAPI mouse and the Bellabit data sets. With the data, you can already view that. The SAPI mouse has much more users, while the Bellabit has lower users but higher sessions. Now, the issue with SAPI mouse was that since I will explain later in my approach that I was using a CMA style architecture. So this dataset has led to a huge class imbalance, which I have to deal with. While this one is better as it doesn't have that much class imbalance. Now, from the original data, original features I had mentioned, we had performed feature engineering like statistical and behavioral features, speed, acceleration, click rate, idle ratio, and there were much more features, angular features as well. We converted some Fourier transform features as well. Other than that, we used a temporal embedding model to basically convert the sequential data into embedding. Now coming to the actual model architecture, what we did is for the first session of any user, we actually can't verify if the user is the original user or not. We are assuming it is true since other multi-factor authentication verification takes place. Now, when the user enters in a second session, we use this architecture. So what happens is we use the session data, we perform the feature extraction like we had previously mentioned, the various features we extract, then it has to undergo data preprocessing for the next CMS encoder layer. So we generate pairs of positive and negative. Here we use balanced batching. Basically, there was a huge class imbalance, mostly of close to 1:40. So for dealing with that, I had to use balanced batching, and I will mention later that I had to use focal loss as well. Now this goes to a common Siamese encoder. You can see that it processes the temporal. It comprises of temporal encoder as well as the statistical encoder, and we used its merge representation to get the embeddings. Now, like say the session A is the already verified embedding, we are getting it, and session B is the current embedding. We are converting both to embeddings. Now, in the CMS architecture, this was the CMS part, that is the twin layer. Now comes the merging part where we compare the embeddings, you can see here, and pass them through a neural network to a similarity head, fully connected layer and the sigmoid, which will tell if they are actually true or impostor. Other than that, like I had previously mentioned about the embedding stored instead of raw data, you can see the verified sessions I'm already storing in the vector store as embeddings. And when the next session happens, let's say that the new session comes into in this for session B. Session A, I don't have to actually process through here. I can directly retrieve from the vector store itself. This saves a lot of compute as well as provides more security here. So regarding the training and evaluation, uh, the balance batching, like I mentioned, is for each batch equal number of positive and negative examples so as to not train the model on imbalanced data. And I had to use focal loss as well, since normal loss don't handle the class imbalance in such an effective way. Regarding the metrics, I used F1 score, accuracy, as well as AUC, area under ROC curve. You can see the results here. These are some of the existing approaches. As you can see that these three are mostly the open set and the privacy aware are our most advantages. These two things are the best things our proposed approach provides. Other than that, we have almost close to or better accuracy. Most of the work didn't focus on F1 as they didn't deal properly with the class imbalance that had taken place. Now onto the two sample plots. Uh, in the right side, we have the ROC curve. This is a sample representation of how our data was trained. And in
Excuse
the
me, sir.
sure, yes, sir.
Just a reminder, you have 2 more minutes left. Thank you.
Sure, sir, I will wrap it up. And in the left plot, we can see that the sessions are represented in the TSN space. I plotted them in the embedding space. You can see that the two closer colors represent the two same sessions and they are closer to each other for almost all the cases. For the negative ones, you can see sole ones like this. Now, regarding our future work, we have to deal with multimodal data, like including keystroke. We have to make our model more interpretable. And other than that, we have to deploy a real one where we can actually deal with real-time data. And the most important of them all is the drift embedding part, where we will adjust the embedding so that it can deal with drifting user behavior over time. Thank you, sir.
Okay, thank you so much for your presentation, sir. Dr. Modi, any questions for our speaker? Hello, Dr. Modi. Okay, I think he is still inactive. No worries. Thank you so much for your presentation, sir.
Thank you.
Yes, and that brings us to the end of technical session 11F. I sincerely thank all of our authors for their excellent presentations and contributions in this session, and also all of our participants for being a part of this conference. I hope this session was informative and knowledgeable enough for all of us. And on behalf of the entire team, I thank all of you for the support that you have shown during this 11th version of the conference and all the previous versions as well. We will be more than happy to host all of you back in 2027 for the 12th version. Just a small announcement, all the presenters will be getting their digital certificates within 2 to 3 working days. And the publications will be live within 7 to 8 months. So kindly cooperate with team ICTIS. I also thank our session chair, Dr. Modi, for chairing this session. This is just a small token of appreciation on behalf of team ICTIS and Global Knowledge Research Foundation. Thank you so much for your valuable presence, everyone. Just a small request, can all of you please turn on your cameras for a quick snapshot of this conference? Okay, no worries. And we're done. Thank you so much, guys. Have a great day ahead.